Welcome. It's nice to see you here. Really, before we start, we'd like to thank European Industrial Installation Foundation and Andreas Götler very much, who will moderate. He has been really instrumental in making this workshop happen, setting up the program, joining people and bringing together his member companies and everybody else that made this possible. So I'm really, really grateful for that. I also am very happy to have from the Eceee project, Robin Backhausen, who is one of the members, but I mean, you are many partners and that works with energy audit. So we had the chance to have this presented as well, which I think is a good opportunity. There will be, as always, when people arrange workshops, including us, there are more presentations than you imagine in the beginning because there's so many interesting things to say. But I really think we have a nice program today with a policy and then concrete examples of what you could do. And then we'd like to hear everybody winning with an open microphone, and Andreas will lead that. So I'm really looking forward. I hope it will be useful. I'm also, as you see, we are filming the workshop. We're also filming the plenaries to put them out as a resource afterwards, so we can, you can share with colleagues and with others to see what's happening in Europe right now. This conference is very much about industrial transformation, the very deep things that need to happen. This workshop also deals with that in a way, but much more on the short-term things that we need to do here and now and what we can do here and now. So the floor is yours, Andreas. Thank you.
Thank you very much, Niels. So yeah, warm welcome also from my side. I'm the Foundation Director of European Industrial Installation Foundation, and we all experienced this morning what the typical installation life is all about when you try industry to convince to use more energy efficient installation systems on the pipes, vessels, and so on. You usually don't go through the front door. You go to a back door, side door, which you first have to seek for, like we all experienced this morning coming here. So I'm very grateful that you made it. EEE not always goes through the front door. But I guess if many of you go to presentations to different conferences, I can just tell you the last one I went to was in November, Global Installation Conference, and I'm going there since 2011 from time to time. And this time I made the experience, I was not the only freak to talk about energy efficiency. Even a machine which is actually bending metal showed that it is saving energy. So it's a topic of today, of course, and what we want to give to you. The motto of this workshop, workshop is savings in a hurry, and we need to save immediately, and we put together with Niels' help I think a very interesting interactive program today. We planned 30 minutes at the end to have a really interactive discussion with you, open mic, feel encouraged, but I think I speak for all the presenters. If there's an urgent question right now, we have a mic and you can ask, of course, right now, and the presenters, all very professional, will of course be happy to answer this. So first we will start with an update from the European Commission, and I can tell you Niels and I have been really busy chasing someone from DTA Energy, and I don't know how many it was in the end. They're very busy with the trialogue, and then Oronzo D'Aloisio offered himself as a worst case scenario. And you know, sometimes the plan B is a plan A+++. And I'm really looking forward, and thank you very much. Oronzo has over 10 years experience in energy and sustainability, and he has been working in industry in the private sector, and currently he's a project advisor at the Live Clean Energy Transition Team at CINEA, European Climate Infrastructure and Environment Executive Agency. And he's the perfect European example. So he graduated European Studies with honors at King's College in London and at the Paris Institute of Political Studies, Sciences Po, and holds a Master in Diplomatic Studies from the Italian Society for International Organizations and the Italian Ministry of Foreign Affairs. So you can't be more European. The floor is yours. Thank you very much.
Thanks a lot for the kind introduction. Indeed, it's a very busy period for colleagues in DG Energy, and so Robert asked me if I could deliver this presentation on behalf of Edita, who is the colleague, actually the only colleague working on energy efficiency and energy audits and energy management systems. Now, indeed, I work in CINEA, which is the executive agency of the Commission, the Green Deal agency, so to speak. Amongst the programs that we manage and the projects that we manage, Energy Efficiency Watch, which is the project that is contributing to the organization of this event. DESME also, which I think will also be presented. So indeed, we have this good equilibrium of work between policy and projects and synergies between the two of them with colleagues in DG Energy. So I'm very happy, to replace my colleague Edita today. And the topic is also very interesting. Is not is not a topic that we're used to talk a lot about energy efficiency and businesses and industries, especially because from a legislative point of view, there is less on this in terms of obligations compared to, say, other consumers. Now, first of all, the 50 for 55 package, you know, it's the most ambitious revision package ever put forward by the Commission. I will not, of course, go into all of that, but I selected a couple of examples that may be interesting for you because there is something related to industry and SMEs in there, and that's the EED, which, as you know, increased, was recast, increased, first of all, the ambition of targets for primary and final energy consumption, but also is looking into updating and revising the obligation for companies to undergo energy audits every 4 years and or having an energy management system. Now, what came out from a study, an impact study that the Commission carried out, was that in the current Article 8 of the ED, so the one placing an obligation of those businesses that are bigger than an SME. When we mean SME, we refer to the 2003 Commission decision recommendation on the definition of SME. So currently the obligation is for those companies being bigger than SME, and what was found out is that member states were facing many problems in the implementation of that obligation for companies precisely due to the difficulty of having of implementing that definition at country level, because of course it may vary from country to country, and also the fact that there was no obligation to implement measures recommended by the audit, which would a little bit undermine then the role that was meant for them to have. So this recast is proposing, in the recast the Commission is proposing for this change of the obligation, a shift of the obligation from the company size to the energy consumption of the company. So currently the threshold proposed by the Commission is of 100 terajoules for the obligation to have an energy management system in place, and 10 for an energy management system or an energy audit. And what the latest, let's say, developments in this sense is that the European Parliament is trying to go even beyond, so with the ambition, they propose to lower these thresholds, which would then practically increase the number of companies that would fall under the obligation. But the position of the Commission so far is that that a careful assessment would need to be done on whether by increasing the number of companies that fall under the obligation, there still is a cost-effectiveness rationale behind it. So, and the first data do not seem to go into that direction, so we will see how the dialogue continues. Another interesting point that the recast would bring about is the inclusion of two new additional quality, minimum national quality criteria for energy audits. So we're talking about Annex 6 of the ED. One that is the obligation for the energy audit to clearly indicate which energy efficiency or measures can be implemented by the company. And second is the obligation to include the potential, an assessment of the potential of the business to self-generate and self-consume energy, for example, via renewable sources, for example, via PVs, solar panels. That is interesting because, for example, also in the Renewable Energy Directive, the only bits where industry and SMEs are touched are linked to the mainstreaming of renewable energy. So the Commission is asking member states to increase the uptake of renewable energy amongst businesses. And one of the ways, for example, the innovative ways that are being brought forward is, for example, with energy communities, because SMEs are also part of this concept, although, as I said, statistically, we see that less happening on the ground. However, SMEs are also meant to be part of the energy transition as energy communities with other SMEs, with energy cooperatives, with local councils. That is open. However, well, that's an opportunity for them. And that's for a bit of the longer term, what the Commission is in a way doing to support businesses in the clean energy transition. In the shorter term, REPowerEU, as you know, is the instrument that the Commission has put forward to phase out dependency on Russian fossil fuels by 2027. You may be aware that the rooftop solar, heat pumps, and in general renewables are at the core of the strategy, which is based around three pillars: accelerating, in this sense, the clean energy transition, reducing demand, so becoming more energy efficient, and diversifying energy sources. Linked with energy audits, the fact that as part of the REPowerEU, the Commission issued the EU Save Energy communication, which, again, on top of a short-term and long-term view, in the short term, of course, calling for energy savings being made through small behavioral changes that everyone, including businesses, can do. And on top of the long-term outlook, which is looking at possibly strengthening structural change towards energy efficiency, the Commission was also asking member states to consider additional measures, additional improvements, and amongst these, the strengthening of the implementation of energy audit results. Why is that? That is because, of course, in energy audits, businesses can have a clear idea of which measures they could be implementing to reduce their energy consumption. So those measures, so the idea of the Commission is that companies could engage into the implementation of measures even before the new obligation starts, the new obligation arrives. And in this, member states could do more to promote energy audits and the implementation of their recommendations. Finally, a few words again on the short term. Another measure that the REPowerEU is putting into place is the Safe Gas for Safe Winter package. And here again, the idea is to help member states reduce gas demand by 15% from the 1st of August to the 21st of March 2023. On this, the Commission has already issued a guidance on the prioritization criteria that should be used in case of serious disruption of energy flows into the EU. Some member states have already communicated a mid-alert level in this sense. And I found this slide interesting for you to see which are the sectors that the Commission has considered as critical to, for member states to protect in case this happens, that are, of course, health, safety, security and defense and food. But also the fact that one of these criteria is the potential damage to installation. So businesses are invited to make a reflection on what would be the impact on their machinery if such a disruption would take place, for which they would be encouraged to increase the resilience, their resilience in this sense. And finally, the most recent emergency intervention for high prices, which is an initiative that the Commission is putting into place to try and use the extra profits being made for the low-cost power generation, to use this into a solidarity, as a solidarity fund, so to speak, that member states can use for example, compensate consumers, to compensate, why not also small businesses, and to help them promoting projects at local level that go into direction of renewables and energy efficiency. And I will stop here. Thank you very much.
You said in the Energy Efficiency Directive recast, we have this 100 terajoules and 10 terajoules, and now I was also a little bit informed there's still the discussion with the Council going on to lower, let's say, this level. Are we talking about 50 terajoules and 5 terajoules, or do you have an idea in which direction or where the limits will be?
Yeah. So the the proposal of the Parliament is to reduce to 18 terajoules from the 100, so the obligation to have an energy management system, and from 10 to 3.6.
Wow.
Terajoules, yeah, the obligation.
That's a very big step, and I think a very good news for the energy efficiency community. We did about 2,500 energy audits over the past years, and we could really see that the energy audit is of course nice because it identifies, but in complex industrial processes, energy management is much more efficient because it's done internal with external help. So I think lowering these really from 100 to 18 and then from 10 to 3.6 is a very big step. So very good news for us.
Thank you. It's related actually. In the past, we always had this problem that there was an obligation for energy audits, but no action on the energy audits, because it's one thing to audit and to make a statement, this is not working well and there you need to improve, etc. But then you can put it in your drawer and you never ever look at it again. So how do you see it with this recast? Will there be an obligation to act?
Well, I think we will hear in a moment the experience of the Netherlands, which is one of the few countries where the obligation is already there in terms of implementation, and it's linked, I think, to the return on investment. Now, as you can, I mean, of course, it will depend on how the negotiations go. Of course, I guess for the energy efficiency community, it would be good news for some part, of course, if an obligation was introduced. But of course, in my personal view, that needs to be backed also with evidence that we're doing something that is cost effective and that will trigger substantial savings, that we're not just putting an obligation. Well, and also something to be taken into account is the fact that currently the return on investment might be very low. How do we deal with then a medium long-term outlook in this sense? Yeah.
This is exactly what Robin Barkhausen will give us from the DESME project, will give us an overview what is actually happening on the national levels to implement the energy efficiency ideas, improvements, measures you can do. Robin works as a researcher at the Competence Energy Technologies and Energy Systems Center of Fraunhofer Institute for Systems and Innovation Research, Eceee, since February 2021, and in parallel he's writing his doctoral thesis at the Technical University of Darmstadt. His research areas, couldn't be better, include the qualitative and quantitative assessment of technologies for improving energy efficiency in households, trade and industry, as well as the development of studies on the eco-design of products with a focus on circular economy aspects. And he will speak about the national initiatives giving audits leverage. So exactly the question from Andrea, an overview of the situation in various countries. So Robin, the floor is yours.
I will a bit, I think, add on to my previous speaker and go a bit more into details on Article 8 of the Energy Efficiency Directive. So we've seen this nice overview over all the things that are happening on the European level. And I will touch a bit on the things that we are doing in the DESME project, which is a Horizon 2020 project, and then go also a bit on the examples of Netherlands and Germany. But that just maybe a heads up in the beginning. I'm not an expert in the Dutch regulations, so maybe we can enter a bit of a discussion here later on. I'm not sure if there are some people who are have some experience on maybe how it is going in the Netherlands. So national initiatives giving audits leverage, an overview of the situation in various countries. This I think I can skip because Andreas, you already introduced me. So the Article 8, we already heard it. Basically, of the Energy Efficiency Directive, it mandates enterprises that are not small to medium-sized enterprises to conduct an energy audit every 4 years. You see here the definition of what is a small or medium-priced enterprise, so it's defined over the number of people, so it has to be mandated to do the energy audit more than 250 employees or a turnover or balance over 50 million or 43 millions. And this is active since 2012. And as we can see in this graph here, there's a very diverse policy landscape in the EU in terms of what are the countries actually doing to support this energy audit obligation. So we see here in the measurements of regulatory instruments in the blue, color shaded voluntary agreements, and then on the top right corner, financial instruments, and the lower right corner, informational instruments. So we're seeing in terms of who is doing what, there's a lot of difference happening. And I think it makes a lot of sense if we see how different the European countries are in terms of the number of companies they are having and also the financial means, of course. And this is taken from a study from 2016. So what we were thinking in the DESME project, we started in September 2020 and I joined in 2021. Basically, we have the goal, basically it's a two-sided goal. On the one hand, we are focusing on companies where we're trying to help them manage their energy transition by taking profits of the multiple benefits. So basically, increasing the leverage of the energy audits. And on the other hand, we are looking at the national authority and seeing, okay, how can we support actually them in implementing Article 8 of the Energy Efficiency Directive. We are a consortium of 9 partner organizations from different European countries, both academics, research organizations, but also national authorities are in the consortium. So we are a bit over half time now in the project, and that gives some time to report on some of the findings. So like I said, the one side of the DESME project is focusing on companies, where it goes a bit to further develop the energy audit approach by also including the multiple benefits of energy efficiency. You see here on the right side a graph actually of a methodology that was developed within the DESME project, where it's really, you first look at the business model of the company and then take a look not only the mere energy savings, but on top of that, which actually benefits from the energy efficiency measures could be utilized or could be convinced the companies to actually implement the measures. And we are conducting some trainings in 4 selected countries, which are Bulgaria, Germany, Italy, and Poland. 2 rounds of trainings where we are trying to, guide them basically to implement this improved DESME approach. And then the other side of the project is focused on national authorities, and this is the part where we as the Fraunhofer mainly contributed. And what we did there, we first scouted for which challenges there actually are on the European market. So we did some surveys and interviewed with selected national authorities on the European level. And we identified 10 challenges, and then we added an additional challenge with us focused on the non-energy benefits. You see we distributed them into the ones that affect non-SMEs and the ones that affect SMEs, and then we subdivided them into a total of 27 sub-challenges. And I will give a few examples of those later on. We then went back to the member states, and this time we looked at all the European countries, and I said, okay, for these challenges, which best practices are actually already existing? And we did identified in this process 50 best practices, and based on that we derived 55 solution strategies for those 10 generic challenges. We transformed those into an interactive guideline document where you see here the barcode, so you can also access it online, and then we distributed those ones back to the national authority as a hands-on guide. And I will provide a few insight basically into those challenges and the solution strategies. The first challenge is the limited resources for transposition. So basically what the challenge says is that of course the cost of the national authorities to transpose Article 8 of the Energy Efficiency Directive, you can basically separate it into the initialization cost in the beginning of the process. You have to implement basically, set up the system, identify the companies, and then of course you have reoccurring costs because every 4 years the companies have to do the audits, so you have to monitor what is going on, and those continuous works. And there's a trade-off, of course, between both type of costs. And one of the best practices we identified here is to automate an automatic submission platform for the companies where they actually type in basically the results of their audits. Because it is still common in many countries actually that the audit results are sent via email, via like Word PDF document, and then the national authority has to collect it from all these companies, and it's quite a hassle. And of course digitalizing this process is quite a good example to mainstream basically, or make it much easier to actually process the data and also monitor what is going on and monitor also the success of the energy audits. A second challenge I want to tip on is the challenge on quality of the energy audits. There I think there are three factors which influence this. On the one hand you have the quality of the auditors, which you can influence by require certain certification schemes for the auditors to make sure they are well qualified. Some countries do that. They have the mandate certain job experience or some trainings. And of course, you can also provide the list with certified auditors. Some countries are also doing it, that they're actually allowing auditors from neighboring countries to be also allowed as an auditor in their own countries, which of course then expands the scope of people who can actually do the audits. Then the clarity of the procedure is an important aspect. If you make it very clear what actually you expect from the companies in the energy audits, this is of course facilitating the process and reducing the mistakes that auditors and company are doing in this process, and by providing guidelines and templates, this can facilitate this. And then of course lastly there's the quality control of the reports. So a lot of countries perform basic validity checks, just seeing did the companies do the audits or not. And then you can also do spot checks, which are more in-depth basically, and well, there we saw a lot of differences in how many countries are doing and how in detail those assessments are. Two best practices, best practices here. We saw in the case of Germany basically what they very recently now implemented, that the auditors have to do regular trainings. So in the beginning you have to be actually qualified to be an auditor by providing that you have the proper education and work experience. But then even if you're an auditor, you're required to conduct 16 units of trainings. One training is 45 minutes within 2 years to actually make sure that the people stay on top of the new technological trends, and not that they're basically not aware of what is happening technological-wise. The second example here is from Ireland, who provided a very detailed and nice guideline on how to conduct the audits, a 65-page interactive PDF document, which we see here. So it's really a step-by-step, takes you basically through the entire auditing process, and also provides some calculation examples, so makes it very clear what is expected and very in a very nice way to digest also for the companies and for the auditors. And then the last challenge I want to talk about here is enhancing the uptakes of measures. So basically, overall, we can distinguish between three ways of doing that. Either the companies, the countries do an obligation, so they say, okay, for example, you have to at least implement some measures, and we saw in the example of Netherlands, they are actually doing it, or you implement all cost-effective measures. And of course, you can also say, okay, we don't want to oblige the companies, we want to more incentivize them and use financial incentives in the form of funding, grants, and tax reliefs, which actually most countries in some form or another are doing. And lastly, you can also use informational incentives by installing a homepage or a tool to inform about which actually financial schemes exist, or organize campaigns and workshops to just, gain a bit of attention to that. Also, for example, Austria, they implement a hotline where the companies can call the national agency and ask for information. Here, the example of the Netherlands. So in the Netherlands, there's this thing called the Dutch activities degrees, which contains environmental regulations, and they are applicable to all companies in the Netherlands. They say unless they have little or no impact on the environment, but I guess it's will be very few companies that really can claim that they don't have an impact on the environment. And then you have specific rules detailed in activities regulation, and actually there's this environmental management activities degree, which has a section on energy savings, and Article 2.15 is on energy savings measure. And on the right here you see all the areas that are actually covered by this activities degree, but for us now interesting is the energy saving measures article 2.15. And basically what it says is that the companies have to implement all energy saving measures with a payback of 5 years or less. And then there are also some definitions basically on what happens if companies are not doing it. So basically they have to carry out an investigation, and it's a bit more specified in the degree. And of course they also have to report this to the competent authorities, then also in a basically 4-year cycle. So these energy thresholds are already basically in place, and it would be interesting to enter a bit of a discussion later maybe to see how are actually companies reacting on those, how well it is working. Because I mean, I will discuss a bit later that Germany is now planning the same thing. In Germany, in terms of informational measures, they implemented a Förderwegweiser, they call it, so basically a funding guideline, which is an interactive website where companies or also private people can go, and they can actually find the proper funding scheme. Because in Germany we have many different funding schemes available. It can be a bit of a jungle, differentiate between the national and the regional funding opportunities. So basically you go to this website, you decide or basically click on, am I a small or a large enterprise, and then it guides you through it, for which area basically are you looking for funding, which type of funding, and then in the end it provides you which funding scheme would be suitable for your company. And now a bit about the recast of the Energy Efficiency Directive. So I mean, we heard it before in the presentation. So in 2012, the Energy Efficiency Directive basically came into force. We saw some amendments, but nothing touched on Article 8. And now we've seen this proposal for a recast in 2021, which actually changes Article 8, which is no longer Article 8, but now it's Article 11, called Energy Management Systems and Energy Audits. So we saw already these thresholds proposed by the commissions, 100 terajoule for implementing energy management system and 10 terajoule for energy audits, and hopefully then they will get even reduced with the proposal of the parliament. Basically what they say, in addition to what was said earlier, it also includes a paragraph that says that the results of the audits now must be transmitted to the management of the company, which was not the case before, which of course the goal is there will be a higher implementation rate if actually the manager sees the proposed measure and sees that they make sense. And maybe earlier it was the case that just the energy manager or some person conducted the audit, but what actually the results never reached the top management level. And then also there's a paragraph to ensure that quality checks are carried out to ensure the validity and accuracy of the energy audits, which, might lead to a higher quality of the energy audits. And we already saw the example of Netherlands, who actually go even beyond what is proposed now in the recast of the Energy Efficiency Directive. So they say, okay, you have to implement all energy savings with a payback of 5 years or more. And in Germany, which is the last example I want to give, they introduced a new ordinance now in September 2022, so it's very recent, and it bears a very nice name. It's called Mittelfristen Energieversorgungssicherungsmaßnahmenverordnung. I think only Germany can create such nice names, and in English it would translate into Medium-Term Energy Supply Security Measures Ordinance from September 2022. And this is a very short-term measure, so it's only valid from October 2022 until October 2024. And it contains, like the title already said, short-term energy-saving measures. And one of those measures is actually that companies are obliged now to implement all the measures that are economically feasible in terms of energy efficiency. And then Germany directly also has a norm to define what actually it means if a measure is economically feasible. It's this norm on the top right there, the DIN N 17463. And then it's defined that the positive net present value after a maximum must be reached after a maximum of 20% of the useful time of this measure. And of course, I think it's the same in the case of the Netherlands, so that's why I think the discussion would be interesting, that this kind of creates a bit of a conflict of interest, since the companies are the ones paying the auditors, and then the auditors kind of having the power to say, okay, you have to implement a measure. So there could be some pressure from the side of the company to the auditors. The measures you really don't want to do, you could, a bit not force the auditor, but make him understand that he shouldn't do his calculations in a way that you have to implement those measures. And of course, it remains to be seen, or it will be seen, how well that works out. Also in this Maßnahmenverordnung, there's an exemption for small consumers, similar to what's in the EED. And I discussed with Andreas before that the plan is actually now that in the energy efficiency law in Germany, this mandatory implementation is expected to be integrated as well. So then it will also last longer than these until 2024, that companies will have to implement the measures. And in Germany, this is accompanied by also an informational campaign. And this now really is my last slide, where on the one hand it addresses private households and also companies. And this is basically just quick saving tips, hands-on tips for different areas, just a few sentences, quick tips on how to proper ventilate, on how to do some quick measures on lighting, to do quick energy savings, which we need at the moment. And this hopefully will help to reduce energy in Germany. And that's it. Thank you very much. And
hello, Robin. I'm Erwin Cornelis, and it's with me that you have to collaborate with for panel 3. So looking forward to. Nice to meet you. Thank you very much for your interesting overview. Yet I think there was something missing, and it had to do with the voluntary agreements. And I saw your map. I think it's incomplete because there are voluntary agreement schemes in more countries than mapped. And the link between voluntary agreements and this obligation really doesn't matter, because voluntary agreement is a framework, a national framework or regional framework, which, the companies really have to make audits in context of the voluntary agreements, and also there are also targets to implement these, and usually there are also structures, rigid structures, depending on the country, verifying the audit reports and also the implementation. And this is, the voluntary agreements in some countries are really an important lever or framework context stimulating the uptake of audits and also energy management schemes.
Okay, yeah, this graph in the beginning, it was quite, if you're referring to the one in the introduction basically part, this was from 2016, where it was mapping the different voluntary agreements, but Yeah, it's an interesting point. I think in the Decimal project we didn't, I mean, the voluntary agreements are not in the, so much in the focus here.
And if I just may continue, that might also explain the difference between Germany and Netherlands. Netherlands has been by leading in voluntary agreement schemes on energy efficiency in Europe, so they have been implemented 30 years ago already, and they are still in place. And well, in Germany, they started with voluntary agreement scheme, but they didn't work out. So now it's more the path of learning networks. Yeah, but I think that's an important difference over there.
Okay. Thank you.
Okay, thank you very much for this contribution. So one point Robin showed was the quality of the energy auditor, and we do think this is a special challenge when you go to industry. If you do an energy audit of a building, it's pretty easy. It's always the same. It's an HVAC system. It's the envelope of the building. But if you go into a chemical plant, a refinery, things get really complex. And if you want to do a proper energy audit for compressed air, or the example we will have right now on the table, and technical installation project, our TIPCHEC engineers qualify by experience, by an engineering degree, and participating in the training with a test at the end, where about 10% fail. And we have regular 4 times per year refresher trainings online to keep them always up to date. And this is a rather simple technology and a no-brainer. And that brings me to Stefan Reichinger. Stefan is a senior manager at technical services for Central and Southwest Europe of Rockwool Technical Installation. He studied civil engineering with a focus on building physics. He's one of our senior TIPCHEC engineers and also a certified Frosio installation inspector with a level 3. Stefan, floor is yours.
Thank you very much, Andreas, for this kind introduction. Ladies and gentlemen, I welcome you here in this nice conference, and what I'm expecting from you is this will not be just a presentation, it will be an interactive presentation. So what I will expect from you is in a few minutes to take your phone, to be able to scan some QR codes. What I'm also expecting from you is to nod with your head when you agree and to shake your head when you disagree. So, many plant owners are not that aware of the huge potential of energy savings. And what I always think is one good way is to show them the difference between domestic buildings, where every one of us is living in, and the plants. And I could imagine that every one of you is suffering because of the rising energy prices. So everyone is nodding with their head. So just as a comparison, in a domestic building, we have approximately 2,500 or 3,000 hours per year, operating hours per year for the heating system. While in the process industry, we are running at maybe 8,000 hours per year. Plant owners would really like to run as long as possible just to produce the products in an efficient way. At home, we have the system running at a temperature of approximately 30 to 50 degrees, depends on the heating system. So if you are heating the floor, you would like to run with 30, 35 degrees Celsius in your heating system. In the plants, we are quite often talking about temperatures maybe up to 250 degrees or even above. Just think about steam systems. If we think about the insulation at home in our roofs, we are quite often talking about insulation thicknesses between 200 and 300 millimeters. Yeah? There's someone nodding with their head. Yeah? In industrial buildings, we are quite often talking about personal protection, where we agree a surface temperature of 60 degrees, another nodding head. Then 160 millimeters, at least on the wall for new buildings, in domestic buildings. In industrial areas, again, personal protection in most cases. Then surface area of the insulated building envelope in domestic buildings, around 180 square meters. In case of storage tanks, maybe 800 square meters each storage tank. And just think about the many kilometers of pipelines that you have in a plant, running at different temperatures, running with different diameters. So when we are looking at the diameters, DN32 is one of the biggest pipes in your home, I would expect. Yeah? So 1/2 inch pipe would be mainly the pipe at home And in industrial buildings, we are quite often talking about DN50, DN80, DN200, and even larger pipes, depending on the facility. And the typical insulation thickness at home, because everyone is saying that the energy losses are going into the building, are quite often the diameter of the pipe, so 30 to 40 millimeters. And in industrial buildings, again, not industrial buildings, industrial facilities, 50 to 60 millimeters just to reach the personal protection. So, you agree or disagree? You agree. Perfect. So, that's the reason why we have the so-called tip checks, and this is now for how many years? 12? 12 years now, the way of making the energy losses visible in the plant. And you see me here together with the colleague Luis Lopez-Brunner, who's also working as a technical director at the EIIF. And we have been visiting together one plant, and you see that I'm checking just the temperature of an uninsulated pipe in this case, which is located outdoors. What we are able to deliver or to make visible, let's call it like this, and this is not the pipe here because the pipe was too hot for the heat flux measurement tool, we are able to make the heat loss visible. We are able to make the watts per square meter visible. And you see that the curve is not that smooth, it's going up and down and up and down, and this is quite typical for uninsulated elements, because uninsulated elements are very strong depending on the ambient conditions. So you see the blue line is the wind speed, and whenever the wind speed is going up, also the energy losses are going up. But in total, we can say that we have more or less a stable heat loss. And in that case, it was a massive heat loss of nearly 1 kilowatt. So we have been at 850 watts per square meter. And this is the example of the storage tank, which you will see on the following slides. To make a comparison between what we are measuring and what we are able to save, or what the plant owner is able to save if he invests in a better insulation, or if he invests in any insulation, because quite often also some flanges, valves are still uninsulated, we have the possibility to calculate also the energy saving potential based on European and global standards. Therefore, we have a calculation tool which is free of cost. It's called Rock Assist. I don't want to go into the depth, but what I want to show is that I'm always quite happy if my measurements are more or less 10–15% away from the calculation, which I'm doing as a comparison, because then I can also show the real figures for the saving potential. So many people are also thinking that uninsulated tank roofs are not that dramatic because the surface temperature of a tank roof is typically not that high. You see here a picture out of our process manual. And what I want to show you is the difference of the energy losses. Of course, the surface temperature of a tank roof is less because you have an airspace, an air bubble on top of the fluid. So this means that the air bubble is acting a little bit like an insulation layer, but just a little bit. In the end, what we are also seeing here is that you have a massive higher convection of the air inside of the storage tank. This means it's an energy wasting machine, I would call it, because the energy of the fluid is heating up the air is arising, cooling down at the ceiling of the tank, going back to the fluid, heating up again. So it's a never-ending circuit. And what you see on the right-hand side, where the wall and the roof has been insulated, you see that the convection, the influence of convection is reduced. So while we are losing approximately, in that case, 955 megawatt hours per year on the wall and 619 megawatt hours per year on the roof, in case of a storage tank with a diameter of 40 meters, 16 meters of height, and running at 145 degrees Celsius, we would lose 20,000 megawatt hours per year on the uninsulated wall and still 8,800 megawatt hours per year through the roof. You see that it's indeed the case that we are losing less energy through the uninsulated roof, but it's still much, much more compared to the 619 megawatt hours. And in Germany, there has been released a newsletter of the Technical Association of Contractors in Germany. It's a so-called TAWKSB in Germany. And we wrote it together with a contractor. And this was one example of a tip check which I made in Southwest Europe some years ago. And you see it later in a larger picture. I don't want to go into the detail. There you have the comparison calculations. And if you take now your phone and scan the QR code, you have the possibility to download the article, the calculations, and also some supporting documents, including information about Rock Assist, if you are interested in saving energy in your plant. So you just have to sign or to agree with one checkbox to be able to download all the documents. Okay, now I would like to take once again your phone and to scan another QR code, because I would like to know from you now what you expect, how much is the energy saving potential of such a storage tank. The majority has chosen that the energy potential is at 95% or more. So hands up. Perfect. Then close to the majority, the persons have chosen that the energy saving potential is at 80%. So close to the majority. The real figures compared. So if we compare insulation or heat losses through insulation compared to uninsulated elements, it's quite massive. So in some cases, when I'm doing tip checks, I would say that at least 95% can be saved, and very efficient systems are even going up to 98% in case of uninsulated elements. And the payback time, of course, is quite low in case of 95% of energy savings. Besides the energy savings, of course, you can also reduce the amount of CO2 emissions, because the energy is somehow created. And if it is created by fossil fuels, you are saving also a lot of CO2 emissions. And these 2 years are calculated with the former energy prices. So it's not incorrect if someone is now expecting that return of invest can be achieved within 1 year with the current energy prices. So this it is from my side now, and I would like to ask you now, if you want to save energy in your plant, if you want to discover energy saving potentials in your plant, and I would be very happy if you would then get in contact with me, and therefore you can also scan this QR code that you have directly then the phone number. Thank you
very much. So you can definitely see how enthusiastic tip check engineers are about the work they do. So now you know he could have easily spoken for 1 hour and go more into detail there. What you should really take away is payback is very short. 95% can be saved when we talk about uninsulated equipment. And in our 2,500 audits, we found about 10% of the equipment is uninsulated or covered by something damaged. So it's a no-brainer. And 2,500 examples show there was not one plant where we didn't find potential. And we talk about 1,800 HVAC systems in hotels, hospitals. So also building equipment is very, very interesting to look at. I don't think there are more questions to Stefan. You have all the information in the QR codes. And I would hand over to Yves Bons from Saint-Gobain. We stay a little bit with this technology, but we look at it from a different perspective. The title is Walk the Talk at Saint-Gobain. The internal tip check program, they call it Tip for Best. But before you start, let me quickly introduce Yves is a solution manager for technical installation for Saint-Gobain in the Benelux. Before, he was active within Saint-Gobain in building-related solutions with the focus on energy efficiency, fire safety, and comfort. He holds a master degree in chemical engineering, and since 2014, he's also a certified tip check engineer. So, Yves, the floor is yours.
Thank you very much, Andreas. Good morning, everybody. After this presentation of my colleague, of Stefan, I don't have to introduce you anymore to the potential of energy audits and tip checks. Earlier this morning, we heard about some questions about imposing regulation and everything. When we look at it from our side, I don't think imposing really is, let me see how this works, is always the good way to go, but I think, let's say, a bottom-up approach can work as well. Very short, Saint-Gobain, we're a big company active in glass, cement, insulation, and gypsum. So we're a big industrial group, let's say. And as many of bigger countries in Europe, we have a clear strategy now for 2050 to become carbon neutral. It's often said, and it's not such an easy task to do, especially if you have a lot of industrial equipment, of course. The way we do that is actually based on two main streams. First of all, we look at our own processes internally. So we're going to look to improve the energy efficiencies of our own plants and of our own production. We have a first step, as you can see on the slide, for 2030 to reduce about 50% of our emissions, well, 33% of our energy and 60% of our emissions. And then by 2050, for the whole production, let's say, to go to zero carbon footprint. That's what we do on the inside, but also our customers, of course, our clients, we try to help them to achieve these goals as well by offering low CO2 solutions and products in our markets and enable our customers really to go the same way and to decarbonize their own process. In order to do so, we have an internal program. It's called, as Andreas already mentioned, Tip for Best. It's a bit of a bric-a-brac abbreviation, I'd say, but the tip comes, of course, from tip check, so thermal insulation performance. And the best is our abbreviation to boost energy efficiency, of course, but next to energy efficiency, also safety and temperature control. There's a few things already highlighted. You know, there's industry, a lot of focus also on safety, like if you have uninsulated equipment in a plant, this could also be a safety hazard. So it's always good to tackle those topics as well. And temperature control, if you have an optimized temperature control in your process, if you can keep that more constant, let's say, also the production quality of what you make can be increased. These are additional benefits of doing energy efficiency measures. So these objectives are two. So first of all, again, internal audits. So we have a program to audit actually all our plants around the world. It's a big step, but we started with it, as you can see, already a few years now. But also by doing this, we want to show that we are a big industrial group and we're not different than any other big manufacturers. Even though we make insulation ourselves, we always have to prove this as well. And we want to do this to show our customers that this is the right way to do it. Like we do our work, let's say, to improve our energy efficiency, and we will support our customers as well doing the same thing. And one of the examples is, for instance, that we have a partnership now with Käfer to do this kind of tip checks with their customers. We are now about with 12 to 13 certified tip check engineers within Europe. At the end of October this year, we've done 270 tip checks almost. As you can see, from 2018, there's been a boost actually in doing so. The numbers dropped down a bit because we've excluded Russia in our activities for known reasons, I guess. And if you look a bit at the repetition of which sectors we've done these audits, is mainly in the chemical industry and in power generation, actually. So this is where you can find the audits that we've done with our Saint-Gobain tip check engineers. More important, actually, what were the results of those things? So if you accumulate all the energy savings that we, just with our team of 13 engineers have seen, you can see here that after all those audits, we're almost at 1,000 gigawatt hours per year and 250 kilotons per year of CO2 emissions reduced based on the audits that we have done. I like to use what Andreas very often said, you do this investment in those measures only once, but then every year the savings are recurring, of course, so this is a very big cumulative effect. This is for outside of Saint-Gobain, but also inside. Like I said, we've done already quite some tip checks We're at 22 now in different activities from our group. And you see some results here. Like I said, from 2021, this is increasing dramatically. It brings me already to the end of my presentation. It's very short, actually, to tell you what we are doing. Energy auditing is a very easy way to see low-hanging fruit, as I call it. It's very easy to get savings from that, and by doing ourselves as a company, we want to prove to the rest of the industry that's the way to go, and we can always help you in that as well. So thank you very much for your time, and if you have any further questions, I'm here or later on in the open mic. Thank you very much.
Thank you very much, Yves. I do have a question. So this is a very ambitious program inside the group, and you can imagine that makes us feel pretty proud that our members walk the talk. Was that driven by the TIPCHEC engineers, or was it a top-down from the management?
Well, both, I must say. In the beginning, we were with the TIPCHEC engineers, who were a smaller group, because I think, when I started my training, I think I was only the second one or so. Yeah. And we were trying also to do TIPCHEC audits in our own plants, because of a good trial case as well. And we noticed then it was a bit more difficult. Now, since a few years, we have a clear strategy also from top management. Like I said, to this carbon neutrality to have a goal. It's a clear top-down decision as well. And we notice now as well, in the beginning we were asking plants to do audits, and now it's internally definitely coming from the other side that me and my colleagues are asked, when can you come and do an audit? We tell them then as well, we don't do it for free, and then surprise, but that's how it goes. And so, yeah, there's a real how can I say, a good dynamic within the group to do these audits. And the need is there, and it's also fun to do. And I hope to encourage everybody to do so.
Perfect. Nice to see you so happy with it. Yeah, great. And I think that's really worthwhile. And Thomas, I guess many of you know him, of course, is a long-term, more renewable than energy efficiency, but still energy aficionado. I hope I pronounced that. Apart from closely following the energy transition, both in electricity and heating sectors, he's also walking the talk at home. So at his house, he's the owner of a heat pump and a PV power plant. And in his building, they both don't compete, but they cooperate with each other quite peacefully and successfully. In his professional life, and I guess many of you know him, of course, he represents the European Heat Pump Association as the Secretary General in Brussels. His main responsibilities there are the representation of the industry and the networking and cooperation and coordination. Of course, he's also publishing articles and well known very much for his expertise. He holds a university degree in business administration and economics. And Thomas, thanks for being here, for jumping in, and the floor is yours.
Good morning, everybody. I think you didn't tell me that you would do this on Carnot Street in the Carnot area of this building. So if this is not for heat pumps, I don't know. But I had to rush indeed to come here. I didn't think that Antwerp is so difficult to find a parking space that has an electric charger with it, but it was. I'm not a TIPCHEC engineer, so I hope that is not distracting you and making the presentation less interesting. But I bought a FLIR camera just yesterday, so I could do something that you're doing. I'm talking about heat pumps. So I thought everybody knows that because it was on all the pictures. So it's the brand name is FLIR, and you can connect it to your photo, and it's really cool. I took a photo of my dog already. So I'm talking about heat pumps today. This is completely different. It's not about checks. There will be checks necessary, but then we talk about what this technology can do to replace an energy source. We, as European Heat Pump Association, we are representing manufacturers and stakeholders from every stage of the value chain, and we are mostly looking at commercial applications, residential products, industrial applications, and district heating and big buildings. And when I met Niels and he told me about this conference, I said, well, are you talking about heat pumps? And he said, yeah, well, no, not so much, but it's very important. So then I said, well, I make it possible. A few words on the total market that we are looking at. This is mainly residential, but also maybe I need to speak there. Yeah. So this is mainly residential, or I take... That's more my style. I like that better. So it's mainly residential. We are looking at an incredible increase in 2021, plus 34%. And we expect that similar growth is possible actually throughout this decade. So we would arrive at 4.4 million heat pumps in 2025, and this is also the target that the European Commission has set itself under REPower EU, doubling annual sales. This is not applying to industrial heat pumps, even though the potential is probably even bigger, as I will show in a minute. Then there's a lot to be said how heat pumps are recognized now in policy. I'm just picking out one slide, and this is the first one that I saw the Commission putting a heat pump onto one of its banners. This is the announcement of the REPower EU communication and package, and you see here a residential unit. Of course, you could also put an industrial one there because industrial heat pumps are recognized in this document. The document itself focuses for the decarbonization of Europe's society on photovoltaic, wind, heat pumps, and storage. But then there's another report that was even slightly earlier. The IEA published this report, Net Zero by 2050, and this is one of the first documents that really makes an effort to estimate how much energy savings we have in industrial applications. 500 megawatts per month until 2060. And when I read this first, I thought, whoa, this is really something, but I wouldn't even know who is supposed to manufacture these units. Because even if you look at the big heat pump manufacturers in this world, they probably couldn't do 500 megawatts as of today. Then there is some scientific coverage. This is a paper by De Boer and others. Really, this paper, if you have not looked at heat pumps in industrial applications, this is, I would really advise you to read, because it has all the brains from the universities and research centers writing it and summarizing their knowledge. They conclude that typical I think it was 2020, industrial heat demand in Europe is 1,952 terawatt hours, 37% of which is at temperature levels below 200 degrees centigrade. And we think that up to 200 degrees centigrade will come into reach of industrial heat pumps. We can do 140 degrees today, maybe 160, and then projects are looking at 180. There's going to be a bit more. The Commission has made some nice ideas in Horizon Europe. But what this would lead into is an installed capacity of 180 gigawatts. And if you multiply this by 4,000 operating hours, which seems typical for cooling, that's 432 terawatt hours and 756 terawatt hours. But if you operate it, as you mentioned, 7,000 or 8,000, no, wait, you mentioned that, operating hours. So we see that heat pumps can replace a significant part of Europe's heat demand in these temperature levels, but it will require some heavy lifting. That's myself in front of one of these containers. That's a heat pump that operates at 140 degrees, and luckily an engineer was next to me, otherwise I would have burnt my finger because they use uninsulated pipes at 140 degrees. That was quite a dangerous situation, but of course it's in a container. So we can do temperatures 80 to 200 degrees centigrade on the sink side. So you need, of course, if you want to do 200 degrees centigrade, a certain source that has a similar high. So you cannot go from 20 to 200. Otherwise you have to take a multiple step approach. Or so you need a larger capacity, and you can provide capacities up to 50 megawatts. We are now looking at a district heating heat pump in Denmark that has that capacity, and quite typical in Scandinavia. They have similar devices like that, couple of tens or hundreds. If we look at industrial applications, we typically look at closing the energy cycle. So the ideal case, you take the waste heat. And that's why the title that I gave this presentation. So you take the waste heat from a cooling process or from something else and bring it back to the beginning. And from a European policy perspective, waste heat is going to be considered the same as renewable energy. Rightfully so, obviously, because for the energy system, it doesn't matter if it's waste heat or renewables. Here I just showed how waste heat and energy demands in industry matches quite well. This is for food, paper, chemicals, and the refinery sector. And you can see on the left side that we have a mountain of waste heat that is getting smaller and smaller the higher the temperature goes. And we have on the lower side, we have a mountain of heat demand. And if you put a heat pump between those two, you take the waste heat at 20 degrees, at 40 degrees, at 60 degrees, and lift it up to 100, 120, 140 degrees, then you do exactly what I say, you close the energy cycle. And quite often, this is only a question of terminology, because people will talk about cooling requirements, and then they just discharge the waste heat into the environment without using it. And I think that's the fastest way we can really save energy today. If we look at heat pumps, where can they be used in industrial applications? Mostly it's in drying. A lot can happen in distillation and pasteurization, in commercial HVAC, of course, in process heating, district heating, and food production. I will not go through all of these. And you see the principle of the way it works. We take an energy source, we lift it by evaporating a refrigerant, by compressing it, and then by handling over that energy to the process that is in need. In policy, and that is really important because it wasn't like that before, we have a recognition in the Renewable Energy Directive. There is now in the new Article 22 a mandate for the member states to increase the alternatives to fossil fuel-based energy use and to phase out the use of fossil fuels for processes up to 200 degrees by 2027. As I've said, that cannot all be done by heat pumps, but it can be done by a mix of different technologies, and heat pumps can for sure go to 140, 160 degrees today. The Energy Efficiency Directive makes a similar requirement, and what is now, it's not entirely new, but in the new directive that is currently under discussion, Article 23 says big cities need to create heating and cooling plants, and ideally, obviously, they will also use the waste heat to close the energy cycles. Then I have a few examples that I brought. So this is from the Dry Efficiency Project. These are all operating today. So it's really something where we say it's not conceptual, but these are operating in brick drying in Austria, in starch drying also in Austria, and in manure drying on ships. Because if you go on a cruise, there's a lot of human manure created that needs to be dried because it can't simply be discharged into the environment. Then there is a very interesting study that I would also suggest for all of you to read. It's from Climate, and it looks at how much does it cost to switch away from fossil gas in the food, chemical, and glass industry. And it gives 10 projects that show economically interesting applications where this change and this replacement of fossil energy can be done. Another project is Spirit. Again, it's under Horizon Europe, and this looks at temperature levels of up to 160 degrees. There is 3 demonstration projects in paper, food, and beverage. And I want to take that opportunity to mention that we, as European Heat Pump Association, we are cooperating at the moment with Eceee, the Paper Industry Association, on a project where we want to bring together the technical people from the paper industry with the technical people from the heat pump industry to develop standardized compressors for paper processes. Because one of the things that we are looking at is whenever we look at industrial applications is that everything is one-of-a-kind projects. And we are missing standardized solutions that could be mass-produced and could be deployed on a mass scale. Especially, for example, for dairy plants. A dairy plant should be the standard application for heat pumps, but it's not. A brewery should be a standard application for heat pumps, and it's not. So we have a lot of applications where you could say, technically speaking, it makes absolute sense. In reality, it's not the situation. So I brought this, green stills, and you can see here, you bring all the components, all the produce into the factory at 10 degrees Celsius, you do something with it, and then you bring it back again at 10 degrees. So if we could just keep all the energy inside the factory, that would be quite helpful. And what is done here is really the prototype of closing the energy cycle. It's happening as we speak in the UK, and actually there is going to be a distillery in Ireland going into operation either end of this year, beginning of next year. So I'm very much looking forward to the first whiskey drums after 10, 12 years. Then we have this received a prize. If you know of good projects, we are handing out a heat pump award every year. This is the Innocent Drinks factory in the Netherlands, and it uses 2 heat pumps to close again the cycles, one for pasteurization, one for hot water and melting. And so you have a most energy efficient plant for fruit juice production. And I think that's the second last. Sweets is always good. Mars and Wegel also in the Netherlands. And you see again that the process is integrated. You can use the heat pumps for process water heating, and it's 1.5 megawatts. So it's by no means small devices, as you can see. And then there's my prototype of the dairy plant, Bergen in Norway. They are actually connected to district heating, and they have really closed the energy cycle, and that's operating today. And that should, in my opinion, be really the blueprint for all types of processes that operate in the same manner. Last one, and now we come to the motto of this presentation, use of waste heat. This is an 8 megawatt heat pump. It was recently installed in Berlin. It's using the waste heat from Potsdamer Platz, from all the hotels and office buildings, the waste cooling, sorry, from the waste heat from the cooling, so like that. So it's using the waste heat from the cooling in Potsdamer Platz of the office buildings and is now using it to provide heating for the surrounding buildings and feeds it into a district heating. So here we have 85 degrees up to about 120 degrees. Refrigerant is 1233 ZD because of these above 100 degrees centigrade. And the future may look like this. It's a 180 degree heat pump prototype. It's operating in Norway at Sintef. It has been running already, so it is conceptually proven that it works, and they are working on developing it even further. And I want to close with a thought for you to take home. I talked to one of our members, and he told me we have 60 gigawatts of cooling capacity installed in Europe, 60 gigawatts. And then if we consider that the waste heat is bigger than the cooling, that means about 1.2 as a factor for cooling capacity, for waste heat capacity. So if 60 gigawatts are operating, they are providing 72 gigawatts of waste heat capacity. If you operate them at 3,000 hours, then it's 210 terawatts. And if you do that with gas, if you would provide this heat with gas, it would be 21 BCM of fossil gas at an efficiency of 90%. And Europe is importing 150 billion cubic meters of fossil gas from Russia. This is only one manufacturer that is doing that. So when the Director General of DG Energy, Dieter Jürgensen, came to us and said, what can we do fast? What can we do before this winter? That was in March. I said to her, this is what you can do in this winter, because all these sites have already a permit. You just need to put a heat recovery unit on all the cooling applications, and you will save tremendous amounts of fossil gas immediately. With that, I let you go. I wish all of us a good conference. Thank you very much. If any of you is interested in being more informed about what happens in the heat pump field, we are an association. We have 173 members, and we are represented across Europe. Thank you.
Thank you very much. So yeah, impressive putting a few heat pumps in some plants, and we're there. So that's exactly what we had. As we come to our next speaker, Andrea Vogt. Andrea's experience in the heating and cooling industry, we stay there for now, spans over 2 decades. In 2021, she joined Danfoss Climate Solutions as head of global public affairs and member of the strategy and sustainability leadership team. Prior to that, I guess many of you have known Andrea as leading the European Partnership for Energy and the Environment. She did that for 12 years as a Brussels-based industry association, advocating already for sustainable heating, cooling technologies in buildings, industry, and the cold chain at EU and global level. The presentation title is Application Efficiency as a Solution that can be applied immediately. And you choose if you want to be the runner or if you want to stick to that mic, Andrea. The floor is yours.
So thanks a lot for the introduction, and good morning still, I think, everybody. So Thomas actually said a lot that is to be said about heat pumps in industrial applications, so I won't need to get into very big details here. What I'm going to do is I will pick up one of the aspects that Thomas was mentioning at the end of his presentation, which is the synergies between heating and cooling, which are not getting yet the attention they should get, and where we have a tremendous potential, as Thomas was also saying, to save energy. So just 2 words about Danfoss without going into bigger detail here. It's just to show it's 3 different pillars, power solutions, climate solutions, and drives. And I'm in the middle pillar in the climate solutions, which is the heating and cooling. So what I'm going to talk about, as I was saying, is about cooling, basically, and more specifically about critical facility cooling, and that can be in industrial applications, it can be hospitals, it can be supermarkets, it can be data centers. There are a lot of applications around where we do absolutely need cooling, and where then the waste heat from the cooling is basically just wasted and it's blown in the air and not used, although we have a tremendous potential there to use it as well, and by doing so saving energy in terms of generating the energy. And you see here on the right hand side of that slide, you see that how it compares in terms of the temperatures, and from the excess heat from cooling, the temperatures are relatively high if if you compare it to geothermal, for example, or also to ambient air and water-based refrigeration. So when we're looking at Danfoss specifically, and that's just an example from our campus, but it's applicable to all sorts of production sites, obviously, then a little bit like the gentleman from Saint-Gobain was saying, we also have a commitment to become carbon neutral by 2030. And in all our global operations, in the Scope 1 and Scope 2 emissions, and at the forefront of this commitment is our campus in Norborg, where you can find the headquarters of Danfoss, which will actually be carbon neutral by the end of this year. So this is really our front runner. And as you see here on this slide, we have on the one hand side the electricity, on the other hand side the heat. And in terms of electricity, it's pretty straightforward. Well, straightforward. It's green electricity, obviously. And then if we're looking at the heating, that's where this presentation comes into play. There it is very much about recovering the heat from the cooling processes in our plants and also from the data center. And then the rest of it using green district energy. All of this is connected then to the district energy network of the Norborg village, which is a small village in the south of Denmark. So I'm just clicking this up. So if we look a little bit closer, this is just giving the a bit of the insight into how this works and why this is very energy efficient and also avoids wasting the energy. It's basically a sort of symbiosis system which uses, on the one hand side, produces the cooling and on the other hand side recovers the excess heat from the cooling, which can then be used for heating, so upgrades it to the temperature needed for the heating. And if we look at the coefficients of performance, then we see that if we only had an air-cooled chiller to produce the cooling, then the coefficient of performance would be 5.7. If we only had a water-to-water heat pump, then the coefficients of performance would be 5.3. But if we bring it together in this combined heat pump, where on the one hand side we produce the cooling, then we recover the heat, upgrade it, and then use it for the heating, then we have a total efficiency ratio which is much higher and which is 9.5. So on the one hand side, this is super efficient, and on the other hand side, it also makes sure that we don't waste energy. And I think in the situation in which we are today, we cannot really afford wasting energy. And it is a very quick measure, as Thomas was also already saying. So if I'm just summarizing what we've been doing in this field in terms of recovering excess heat and having this symbiosis approach, this is just an overview of the projects that we've been running over the past years, more than 140. And it shows on the top graph, you see the number of projects selected according to where the cooling and the excess heat is then needed. So as you can see, process cooling is one of the very big, is one of the priorities where this sort of symbiosis approach has been applied. But you can also see that there are a lot of other applications where this obviously also works. And then at the bottom graph, you see the average temperature ranges on which this is operating, and there you can also see that there is quite a big span. So there is a large, really a large opportunity to use those symbiotic approaches between the cooling and the heating. And in terms of a summary, then we have the process, the wastewater, the district, and the data center cooling, which represents 44% of those projects. And the gentleman from the Commission earlier was speaking about, was giving this nice summary about what's being right now discussed in terms of the Energy Efficiency Directive recast. And on one of the slides, I think it was on your slide, if I'm not mistaken, there was the data centers mentioned as well. There is this big opportunity opportunity from data centers. Data centers, we need more and more data centers. Everybody knows that. Data centers need cooling. Everybody knows that as well. They use a huge amount of energy. That's also not rocket science. So this is really one of the key examples where we can really make use of this synergy. Produce the cooling with a heat pump, recover the heat, and then upgrade it, and ideally feed it into a district energy network around it. The problem that we see in reality is that even if the data center says, okay, I'm fine, I'm going to apply this, I'm going to recover the waste heat, very often then there is the stumbling block that either there is no district energy network around, or the data center is far, far away, and then where would you use it then, the waste heat? Besides the data center itself for hot water, for example. Or the district energy grids, if there is one, is not ready to accept that heat. So there are quite a few stumbling blocks that unfortunately are still standing in the way of really applying this systematically. I think it's changing. We all see it changing. We see that it's more and more considered. But I think a stronger push here would really be beneficial for everybody, and specifically, of course, also in terms of the energy use. Germany, for example, has now proposed an Energieeffizienzgesetz, where there would be a 30 to 40% obligation of waste heat recovery from data centers. It's heavily debated in Germany. Will it come through? I have no idea, but it just shows the thinking of the government, which goes into that direction, and the stumbling blocks that we are seeing today. So it's really a great opportunity. It's not rocket science. It's a technology which is readily available, which can be used immediately, and can help saving energy in a hurry, to come back to the title of this session. And I'll leave it here, and happy to answer questions. Thank you.
I'm Henrik Adler from the Danish Energy Agency. I've been working with energy efficiency for more than 30 years now. And I still wonder why everybody is talking about it's not usable, the heat from data centers, because everybody thinks about making the heat at the data center instead of circulating the cooling water in a colder pipeline system and then have the heat pump in the domestic heating central instead of. Then you only have to transport 30 degrees, cool it down, bring it back to with 10 or something like that. So then the domestic heating system takes it and use it there instead of generating 70 or 80 degrees hot water and bring it to somewhere that only use it once in a while. I mean, why not those cold systems instead of hot systems?
Yeah, I think I think this is not.
Thank you for the question.
I think in any case, Denmark is a very good example, because everything what I was just referring to is basically applied in Denmark. So it's really a sort of a showcase example, I would say. And if I'm just looking at our company, the waste heat that is recovered from the cooling processes is also, I mean, it is recovered among others from the data center on the campus, and is then used, partly the waste heat is used on the campus then for operations on the campus where we need heat, and on the other hand side it's fed into the district energy system of the municipality. So both approaches are being done, and if we could do what is done in Denmark everywhere, I think that would be very helpful indeed. So
I have one more question. You said 2030 to be decarbonized. Is it 2050 for Danfoss, or?
No. For Danfoss' own operations, so the Scope 1 and the Scope 2 emissions, the commitment is 2030.
Wow, fantastic.
Carbon neutrality, yes.
Great. Thank you very much, Andrea. And last but not least, before we jump into the open mic, Anne Berzard. Anne also jumped in really in a hurry last minute for us to support this workshop and to add something we think is significantly interesting for everyone as an immediate action, how to save energy. But let me first introduce Anne. She always had a strong ambition to help fight global warming and has been working as an energy specialist for energy-intensive industry since 2007. But then in 2010, she decided to found her own company called Improve, a climate and green tech company. She built a team specialized in energy management and invested in the development of a software called Analyzer, which is a platform enabling companies to manage their sustainability targets and strategy based on real-time data. And that's what we will be looking at. Improved stands for a very pragmatic approach. Also, this, I think, is always practical approach is needed here. Using the data to get actionable input to optimize an industrial company's energy use. And the floor is yours.
Thank you. I'm already getting hungry. For me, it's good noon, not anymore the morning. Thank you for the invitation to speak here. Andreas told me that there would be a lot of examples about heat and insulation. So he asked me to give some examples of other ways to save energy. So in my presentation, I'm gonna give you some examples, some case studies about how companies can use their data to find savings very quickly. So let me go to the first example. So it's really a very practical presentation. The first example I brought here is of a textile company, and they use a lot of gas, they use a lot of electricity, and actually what they did is look at the standby consumption. So what I mean there is they just look at what do we consume during night times, what do we consume during weekends, and you don't need a lot to do this. So in your own company, if you have your main energy meter, you can ask for the data at your energy supplier, or you can ask it at the distribution network. So you don't need a lot of investments. And if you check then what is being consumed during non-production moments, then you often can be very surprised. Like in this case, the company had realized a savings of almost 50% on all consumption that was non-production times. So it cost almost nothing. They just took the data that was already available and they looked for potential savings. So there's another reason why you should follow up data more in detail. So like your electricity consumption, you can easily get 15 minutes data. If you have a lot of water consumption, it's less easy. So there, what companies do is they put a pulse reader on the water meter, so it's a very low budget thing to do. And again there, if you check water consumption and you can put alarms on it, you can avoid a lot of costs. So this one is an example of a company who's in the food industry. They're producing cheese. And they have this water softener who's regularly leaking water in the system. So if you don't measure, it just remains unnoticed. And it's often a very large amount of water and also a very large cost that they then unexpectedly have. I also brought an example from an air compressor, because compressed air is very expensive. It's one of the most costly utilities in companies. So for compressed air, the biggest problem you probably know of is air leaks. So that's why we always suggest, if you have a large installation, to measure the energy use and to measure the airflow. And then you can, if you check then the airflow on non-production times, you get an idea of how much is leaking. And if you measure the amount of energy you use per cube meter of air, you get an idea of the efficiency. So this is a first example. If you have here, you can see the energy consumption, and you see in the at night times there is still energy use while there is no use of air. So if you measure this, you immediately get an idea of the cost. And this is not a cost that you only have during these weekends. It's a cost that you have all the time, because it's because of leaks. So they're leaking all the time. As you see here, in this case, again, it was almost 50% of savings, and representing more than 100,000 euros. This is another graph I wanted to show. This is about comparing the efficiency of a machine. So if you can calculate, if you know your flow of a compressor for a certain time, and you know for the same time how much energy you have been using, you can calculate the energy per unit of a cube meter of air. And what we did is we took 11 customers, and they have similar installations, and we put them in this graph. And you can see most of them are operating at 7 bar, but like the number 1B and 2, they're the most extreme. So the first one is operating at just 0.1 kilowatt hour per cube meter. And the worst one is 2.5 times almost larger in consumption. So if you look this type of machines, we're talking about 200,000–300,000 euros cost a year. So if you're operating at the level of number 2, your cost will be, instead of 200,000 euros a year, almost 500,000 euros a year. So this is really non-leak problem. This is really compressor efficiency issue, actually. So this is, I think, there's still heating and cooling I wanted to say something about. So companies also can check on their heating consumption, and then you could install a gas meter, or you can put a pulse reader again on a gas meter. So putting gas meters can be very expensive, but if you can have pulse contact, you can read the data from there, then it's very cheap to do. But there's like also a good alternative, and that is simply measuring the temperature indoor. Why? That's because if you see during weekends, during night times, that your temperature is remaining at 20 degrees, then you know that you're consuming a lot of gas while you shouldn't. In that case, the savings are around 30–35%. And also for your information, I put there, if companies can turn down the heat with only 1 degree Celsius, they will save 7%, 6 to 7% usually on their gas bill. So that was a very short addition to how you can realize savings in an industrial context.
So my first question, did anyone go to his cellar and regulate his heating down, further down than to the years before? Hands up, is there anyone in the room except me? Of course, I knew I will ask this question, so I quickly changed that. Very, very good. So that's also a little bit walk the talk. And I have one more question. If water is leaking, how can you not identify? With compressed air, I understand, the air just goes. But if there is water leaking, it must be somewhere in the system, no? It's just evaporating, or?
Yeah, like the most problems we see with water is that it's leaking, like in a water softener, for instance, and they have piping leading to sewage, so it's just disappearing there. Okay. And as water is usually invoiced with advances, and you get the final invoice at the end of a year. You just don't notice. You only see at the end of the year, and if the leak has occurred just before the end of the year, it just takes another year before you really see it.
Of course. So it's really up-to-date data measuring.
Yes.
That's also what you said with 15 minutes. Can you explain with the 15 minutes frequency? What does that mean?
Yeah, the 15 minutes is the standard. also, if you look at legislation, rules, if you look at peak shaving, for instance, it's been on the slides, they look at 15 minutes to determine your peak. So that's why 15 minutes data is for energy measurements is a standard.
Okay. Did we forget about a technology, savings in a hurry? Is there someone in the room who knows something more, not just heat pumps, not insulation, not just, let's say, monitoring, of course, and evaluating of data? Is there an example? Yeah, so I will go to you again.
I just want to precise what you said. It means that you get 4 measures an hour and 96 measures a day. So you get an average measure every 15 minutes in your system. You can also run in seconds or in minutes, but this is prepared for only checking every 15 minutes, which is more than enough to cover and find the savings.
It's a standardized way.
In a compressed air system, I would go down to 1 minute or even 5-second terms if that was very special to focus on. But in average, 15 minutes is a very good measure period.
Okay, thank you very much. So we are in the open mic session. If there is nothing, I would just ask something, walk the talk coming here. Who arrived in Antwerp by plane? That's only one. Did you do the offset? Sorry to ask. No, you don't have to answer that. So all the rest arrived by hopefully train, or maybe who came by car? Hopefully a super nice consuming, well, very little consuming car, or even electric renewable.
13 hours by train yesterday.
13 hours by train. That's double that I had, but congrats. It's actually, I came here from Switzerland taking a Swiss train, then taking the TGV, and then taking the Belgium Thalys. I had not 1 minute delay. So I took the right direction. 5 changes in Germany. Oh, that's a nightmare. Yeah.
Question?
Yes, of course.
Yes. So to clarify, I haven't been on a plane for 3 years.
Yeah.
if that helps. But I had 2 questions. One to Anne. So many years ago, I heard that companies don't want to use electric tools because they get stolen, even if they're much more efficient than compressed air. So I wonder if you could say something about that. And then I had a question for Thomas, if you could elaborate a little bit on the flexibility of electricity demand and thermal storage opportunities here.
Okay.
It's I'm a bit surprised, I have to admit, because it's the first time I hear this. So yeah, we work for, I think in the meanwhile, like 100 large industrial companies, and I've never had this remark. What country were you from? No, and just maybe for later, I also have a question about the high temperature heat pumps on the efficiency, because I sense a lot of reluctance to use it because of the efficiencies. So I'm curious to know at what level they are.
Yes, thank you. So maybe we start with the efficiency of the big heat pumps. Of course, it depends on the delta T between the source and the sink. Normally, you can cover about 70 Kelvin per cycle, per step, and then you can achieve an efficiency of about 3. The higher you go, the lower, but obviously, if you can save half of the energy at very high temperatures, it's also a very high savings in absolute terms. So I don't think that there is a lot of well, people are not using heat pumps because they are not efficient enough. And as Andrea showed quite clearly, if you if you connect the heating and the cooling cycle, then your efficiency is much higher. You can at least add 1 to that. So if you have heating and cooling at the same time, you would have an efficiency of 3. And as we saw, if it's done in an optimal mode, then you can do up to 9.5. And that's still below Carnot efficiency. So maybe we could even do more if we would put some more research into the topic. And we talked about, you asked about flexibility and demand side potential. We have calculated that based on our sales data on the stock data for all residential units, and then we can say it's around 4 terawatt hours, assuming that you can do 2 shifting cycles per day and you can shift load for about 24 hours. Depending on your system design, you can do much more. I would say in my own house, I can switch off my 400 volts connector. I will not switch off my house from electricity, but I can switch off the high voltage part for 2 days because I have a 600 liter water tank, and then that will help me to save that. In industry, it's more difficult because most industrial processes, the people say we're not here to save energy, we're here to produce milk, whiskey, water, paper, whatever you have it. So they say even if we can save 2-3% by shifting our load, we will not do it because operations accuracy and operations quality is more important than saving the energy here. But you will still save by deploying the heat pump. And on these electric tools, I want to add one thing. It wasn't a question to me, but I was at an event 2 weeks ago where they were looking at how to optimize heat pump production lines. And they said one of the most impactful choices is to replace a hand screwdriver with an electric screwdriver. And you would be so surprised how many factories still use hand tools instead of electric ones, despite the benefits that they have.
I totally agree with you. I've met that question many times, and I've been in very many factories around in Denmark, that earlier it was a bigger problem, if you could say so, that electrical screwdrivers, drilling machines or whatever was not accepted in the production. Therefore they used compressed air equipment instead of, because as you say, someone said, oh, it's going to be stolen. But there's another thing, and that is where EU should really focus on. When you buy a machine, a packaging machine, whatever, a saw, whatever it is, all sort of industrial machinery today are still equipped with compressed air components, because it's the cheapest thing for the machine builder to put on, and he does or she does not care about the energy usage in the factory when it is installed. But using an actuator, electrical, is a little more expensive, but much cheaper to run the next 10 years than having a compressed air actuator that only get 10% out of the 100% you add to the compressed air system. So there's really a way to focus on energy efficiency if we can get the industry to get those components changed, and the customers to demand that they don't want to have that. They want to pay a little more to get electrical actuators instead of compressed air-driven actuators. It's also when you open and close for ventilation systems all over. It's so much energy that we can save if we focus on that.
Yeah, I think that brings us to the point which Alonso also showed at the very beginning, that there is this point of behavior change. So this is a kind of behavior change, not to do business as usual, but to think about existing alternatives. So it's not that we just need to go for innovations. It's really many times just doing things a little bit different. And like this, we can save, of course, a lot of energy. A typical changing behavior is also, I think, very important to make the people working in the plant themselves responsible for the energy consumption they are responsible for. So that is also something where I've heard if companies do that and actually give the responsibility to the guys at the machine to check that the machine is running at times where it's producing, but not running at times where it's not producing, and to make them responsible to survey this process, has shown significant improvements in energy efficiency, which are also magnificent. I can give you one example. We did in a professional washing, how would you call that, company. They were washing the typical cloth from hotels and then hospitals, and they had this ironing machine switched on Monday morning, and the only day they ironed, the TIPJEC engineers working there on the plant, they were working in this warm environment, and they were just not understanding why this ironing machine is emitting heat Monday, Tuesday, Wednesday, Thursday, and only Friday they're ironing. And they asked, why is it switched on? It was always like that, but at some time someone decided that we iron only on Fridays, but nobody changed the programming of this ironing machine. And it can be really very simple like this, and you can imagine, like Anne showed in her examples, this quickly goes to really high amounts of money you can save, and hopefully it's also a little bit encouraging. And I think that is also very important for a conference and a workshop like this one, to take home, to be eyes wide up and to check really what you can do to improve your daily business life. I think we have come to an end here of the conference. Is there one more thing you would like to give us for the... Yes, if you introduce yourself quickly. Yeah.
Didier Bosbeuf from ADEME, the French Agency for Ecological Transition. I am not a mechanical engineer, I am a policy analyst. And when I see the title, How to Save Energy in Hurry, I was thinking not only on type of equipment, but what kind of policy can push the penetration of technologies. And the presentation of our friend from Germany, he say, okay, in Germany and Netherlands, they have a strong, let's say, regulation scheme. And what it's important to say is generally regulation alone doesn't work. You need accompanying measures. And what was missing in your presentation, but maybe doesn't exist, it's an accompanying measure, a subsidy scheme. You cannot say voluntary, mandatory audits without supporting, for example, the investment behind that. So I don't know if they have planned to do that or if you are not just mentioned that, but it's a key question for me. Secondly, a policy in hurry, what's mean a policy in hurry? Because a regulation, you have to think a lot of time before making a regulation, and then to make enforce regulation, it takes time, and so the subsidy scheme also takes time. So I think we have to think also about policies in hurry.
Absolutely.
So this is a two-dimension. Technically it's one thing, but we have to think about policy in hurry. And for example, an audit, a good idea could be to say, okay, we have a mandatory scheme, and the ministry say, okay, we support all the investments which have more than 2 years payback period if you implement already yourself all the investment lower than 2 years payback. I think this is a smart scheme which mixed, let's say, private effort and public effort. So it's more or less a question to you. If there are accompanying measures beside the strong regulation in Germany.
Thank you for the question. Robin, do you want to ask? Do you want to answer, not to ask?
I can also ask another question. No, I think it's a very valid point. And yes, there are, of course, financial schemes supporting the obligations in Germany. And there are also some which actually say you have to do an energy audit before you're eligible for the funding scheme. But it's a variety in Germany, so wide. I was showing this further Wegweiser, which basically helps company to pick the right funding scheme. So I think Germany is also trying to make the companies realize which supporting schemes there are.
I can add to that. Actually, when we do these installation projects, there is a German subsidy program also for the installation projects, but the payback time has to be 3 years or more. So most of the times you don't need to ask for it because it pays itself back anyhow, and you don't need any tax money for that. But of course, for other technologies, the 3 years, 4 years payback time is of course valid, and there you can ask for the subsidy in module 1, 2, 3, 4, whatever they have. So that is connected. But in the Netherlands, I have to say, I don't know. There's this 5 years payback time. I don't know, Gerda, maybe you know if in the Netherlands this new law from 1st of January, the Onderzogsplicht, which also says like the 5 years payback time has to be returned, or they have to do, bring alive these projects. Is there some subsidy program accompanying or some support for the companies?
I'm since the 12th of October the new chair of the VIB, that's the Dutch trademark organization for the insulation technique. Well, we have this isolation scan that's mandatory for industry, and we have that's mandatory also the information obligation that industry have to do, and this payback time has to be 5 years or less. But that was said by you, I think. So.
But is there also, can companies ask for financial support when they need to do it in the Netherlands? Or we need to, that's a question to take with us
I think
to
that's
check. Yeah? In Denmark, you also have it accompanied with subsidies. Yeah?
There are exceptions.
Yeah.
And I think that's for municipals. I think
municipalities,
yeah. And for certain other companies too, but I don't think that's regular.
Yeah, okay, thank you. And then, Elmer? Okay, just because that's for the Netherlands, yeah.
In the Netherlands, we have subsidiaries for the industries. When you apply insulation on equipment which was not insulated, or if you improve insulation, then you can, at the end of the year, you can recalculate your benefits, and you can get subsidiaries from the government. Okay. So there are subsidiaries from the government.
But let's say not in parallel with the audit. Also, like in Germany, it's not in parallel.
It's
just an existing subsidy program which then you use when you identified your measure.
You don't have to do an audit. You just have to show your insulation thickness and
increased efficiency.
Increased efficiency. Yes.
Okay. Thank you very much. And then
in policy in a hurry, you do not need only legislation and mandatory targets, or which is the stick, not only subsidies, which is the carrot, but you also have sermons within the tree, and the main sermon is here. I would like to refer to the learning networks in place in Germany, but also copied from Switzerland, and also in place in Sweden and in other countries. Also, Ireland is having a lot of workshops. Organizing workshops, putting industrial companies together with people like you who are vendors of solutions, and raising awareness of what the problem is and the solution. And this, I think, especially when you have a policy need, when there is a need for a policy in a hurry, this has the quickest effect.
Very good. I think there is nothing to add. Let's go this way. Big thank you, Niels, for organizing this pre-conference workshop. And also, I feel really honored, great pleasure to moderate this session with very, I think, interactive, interesting, very pragmatic presentations. We could see that all the speakers are burning for what they do. Let's be burning for this conference so that we take home very good ideas from here. Again, a big thank you to Eceee, Niels, for organizing the pre-conference workshop. A big thank you to all of you. A very big special thank you to our Solution A+++. Wanzo, thank you very much. And enjoy the conference, and I'm very happy to talk with you when we have a coffee break now.